So this lesson is 5.5 to 5.6, multiplying and dividing polynomials. It's a continuation from the last lesson that we did on adding and subtracting polynomials. So what we're going to do now is we're going to move past addition, subtraction, multiply, and divide. So I'm going to show you two ways. I'm going to show you mathematically, and then I'll show you with the algebra tiles again. So monomial times a monomial. So one term times one term. It's really quite simple. You take the coefficients. Remember, those are the numbers in front of the variables. You multiply them together, and then you multiply the variables. Okay, so here, let's look at an example. 3a times 5a times 2a. So what we got is 3 times 5 times 2. That's the coefficients. And we have a times a times a. And those all have 1s above it. So we do this, and we end up with 3 times 5 times 2 is 30, right? And we have a times a, which is a cubed. That's different than addition and subtraction. If it was a, plus a, you just add the a's together. But since we're multiplying, you have to look at the exponents and add those together. Okay, what about if we have negatives and positives? Big deal. So we have negative 3x squared y and 2xy cubed. So coefficients, the negative 3 and the 2. Multiply those together. The x, right? Because that's x squared, so there's 2 of them. And then we have an x here, so it's x times x times x. Then we have y and the y cubed, so there's 4 y's there, right? So if you break it down like this if you want, you don't have to eventually. You'll get into the habit of just going, oh yeah, that's a y to the 1 and a y to the 3, so that'll be a y to the 4. But for now, you can break it down into its pieces. So negative 3 times 2 is negative 6. X times x times x is x cubed. Y times y times y times y is y to the 4th. There it is. You end up with that big monomial there. Okay, what about this one? Just a mix of different things. AB times negative AX times 2y. Well, what are the coefficients? There's a 1 in front of this one, a negative 1 in front of this one, and a 2. So you see 1 times negative 1 times 2. Then we have an A and an A. So our A and our A over here. We have a B, and that's it. No more B's. We have an X. Oh, we just one of those, and a Y, just one of those. Wow, we got a lot of independence here. So basically, you just put it all together. So 1 times negative 1 times 2 is negative 2. A times A is A squared. B is just B, and X and Y. So you end up with this one right here. All right, flip page. So that was, first one was a monomial times a monomial. Now we're going to do monomial times a binomial. And binomial is just 2 terms. Remember, they're separated by either addition or subtraction. So the rule is you distribute the monomial into each term of the binomial. So distribute means multiply, and I'll use that term a lot, distribute. Okay, so let's take a look at this one. So we have our monomial at the front, 3a, and we have in here our binomial, 4a plus 5. So what that means is we distribute this 3a to both terms. You can see why these little red lines underneath, why I did that. And you could draw these lines in as you do it. So the first one you would draw is, 3a times 4a. Yeah, there it is right here, 3a times 4a. And then 3a plus 5. Well, 3a at the positive 5, so 3a times 5. So here, 3 times 4 is 12. A times a is a squared. Here, 3 times 5 is 15, and the a is just by itself. Now, there we go, 12a squared plus 15. Now, careful, don't combine that any further. That's an a squared, and that's an a, and they're separated by addition, right? This is a binomial. You can't stick those two together because they're not like terms. You can multiply them, but you can't add them. Another one here, negative 3 out the front, and a 2r minus 7. So the negative 3 times 2r. There it is, right here, negative 3 times 2r. And the negative 3 times negative 7. The negative 3 times negative 7. So here, negative 3 times 2 is negative 6. R is just by itself. Negative 3 times negative 7 is positive 21. There it is right there. So negative 6r plus 21. Oh boy, look at these. They're starting to get complex. It's really not. It's just you got to keep yourself organized when you do this. So we got to distribute this 5 just to this first binomial, and we got to distribute this negative 3 to the second binomial. Careful, it's negative 3. So the first one is 5 and 2b and 5 and negative 3, right? Second one is negative 3 times 5b and negative 3 times negative 2. So go back over here. 5 times 2b is 10b. 5 times 3 is negative 15. Negative 3 times 5b is negative 15b. Negative 3 times negative 2 is positive 6. Now, in this case, you can combine some terms. You can collect like terms. Oh, see, I boxed the 10b. I can box the negative 15b, or use whatever symbol you want. Use a colored pencil or a line underneath it. Those are like terms. So 10b minus 15b is negative 5b. Oh, cool. And negative 15 plus 6 is negative 9. So once you're done the multiplication part, you can actually collect the like terms. Okay, let's do the next one here. Oh, binomial times binomial. See, they're getting more complex. So the first one was monomial times monomial. Then we added in a binomial. Now we're going to do two binomials. So because this is so common, we actually do something really neat called FOIL, and we'll show you that. So the rule is to multiply each term in the first bracket by each term in the second bracket. A lot of kids forget that. So what we do is we use something called FOIL. It means first, outside, inside, last. It's an acronym that represents those words. So here, let's look at the example here. So first, if you look in each bracket, A would be the first term. So it's A times A. And you can see that's the first thing we did there, A times A. Outside means the furthest on the outside. So that would be the A, the first one here, because it's on the far left outside, and the 2 on the right outside. So it's 2 times A right there, or A times 2, doesn't matter the order. Inside, the 2 that are in the middle here, right? So inside is 3 times A, and then 3 times 2 is last, 3 times 2. Sorry, this one should be 3 times A. That's a mistake on my part. That line should be right there for inside. Okay, so we have A times A, which is A squared, 2 times A, which is 2A, 3 times A, which is 3A, 3 times 2, which is 6. Then we, if you look, the only ones we can collect are the middle terms. 2A and 3A is 5. Okay, well, let's do another one. Yeah, the lines are right on this one. Okay, so first, outside, inside, last. First would be x times x, right there. You can see it's right there, x times x. Outside, x times positive 3, right there. Inside, careful, that's a negative 4 times x, negative 4 times x right there. And last, the 2 last terms are negative 4 and positive 3, so negative 4 times 3. Then we do the math. X times x is x squared, x times 3 is 3x, negative 4 times x is negative 4x, negative 4 times 3 is negative 12. We can combine the 2 middle ones. 3x minus 4x is our negative 1x. Now, again, you don't need the 1 there. You could just have negative x if you like. Okay, another example here. First, outside, inside, last. First, 2w times 3w. Right there, you can see it. Outside, 2w times negative 4. Right there. Inside, 3 times 3w. Right there. And last, 3 times negative 4. Right there. This is how you would normally do it. You can see it's all broken down. So we end up with 2w times 3w is 6w squared. 2w times negative 4 is negative 8w. 3 times 3w is positive 9w. And 3 times negative 4 is negative 12. And then what can you combine? Just the middle terms here, the negative 8w and the 9w, which forms your 1w. Or you can just leave it as w if you want. Okay. Now sometimes you're going to get binomials that they're just going to throw, it's variations on stuff, right? You got to get used to that in math. Sometimes they're not always going to give you the exact example that we do. So you got to look at this one, x plus 3 squared. Now careful, that doesn't mean x squared and 3 squared. No, what that means is whatever's in the brackets here, you're going to multiply it by itself. So technically that means x plus 3, x plus 3. Now, if you look, that's a binomial times a binomial. So then we could use FOIL, right? First, outside, inside, last. So careful. When you see x plus 3 squared, it does not mean x squared and 3 squared, which is 9. It's not that. Don't make that mistake. It's super common. That's why I'm warning you. Okay, so let's look at an example here. So we have a minus 5 in brackets squared. So what does that mean? Write it out this way always. Write it as two binomials. A minus 5 times a minus 5. And then again, we do first, a times a, outside, a times negative 5, inside, negative 5 times a, last, negative 5 times negative 5. And you can see a squared, negative 5a, plus 25. Then you combine like terms, a squared minus 10a plus 25. All right. Oh, this one kind of got screwed up on the screen here. This is supposed to be 2m plus 3n squared. Now you can see it down here, just got thrown up here. So what it means is, write it out 2 ways. So 2m plus 3n times 2m plus 3n. And then we again, first, outside, inside, last. First, 2m times 2m, 4m squared. 2m plus 3n is 6mn. Now careful on this one. This is 3n times 2m. So a lot of you will write 6nm. But you have to realize these ones are always going to be collected. It doesn't matter the order when you're multiplying. M times n is the same as n times m. So what we do is we just keep them the same, and then we can add them together when we collect. The last part, 3n times 3n is 9n squared. And then we can collect the two middle terms, and then we have our trinomial. Okay, now let's see what this looks like with algebra. Again, if you understand the previous concept, you can kind of ignore the algebra stuff because It's just a different way to learn it. So let's go back to algebra tiles. Remember, light tiles are positive, dark tiles are negative, little squares are constants, rectangles are variables, and the big squares are variable squared. So what we have here is we have a positive times a positive gives us a positive. So an example would be 1 times 1 equals 1. Here we have positive 2 times 1, so we end up with 2, so it's 2 times 1 equals 2. Now here's the cool thing about negatives, watch, and we talked about this before, when you multiply two negatives you get a positive. What's the same with algebra tiles? So a negative times a negative equals 1 positive. So negative 1 times negative 1 is positive 1. Okay? Next page, let's continue with multiplying. Oh, here we go. So we have a variable times a constant gives us a variable. So that would look like a times 1 equals 1a, or just a. Okay? Here, 2 of these, 2 variables times 3 of these ones, right? So first off, positive 2a, you can see here, times negative 3, right? That would be like, okay, what's 2 times 3 is negative 6, and the a is just by itself. Now, you could, if you wanted to, write out 6 of these things side by side, but that's a lot of writing. So often what we do is we do the shortcut, and we just go 6 with a little bar like that. That represents 6 of the variable, and the being negative, being dark, means it's negative. Okay, what about this one? Variable times variable is variable squared. So a times a, you can see here, a times a is a squared. So we end up with the variables ends up with the variable squared, a big box like that. And again, positive times positive is positive. Okay, ooh, look at this one. Negative variable, so negative a, or whatever variable you want, times 3a. Keep the variables the same, right? We can't change the variables in here. This couldn't be an a and this couldn't be a b. We're not doing that. Yields you, like a negative times a positive is going to yield you negatives, but you get negative a squared in this case. So negative 3a squared. Now, the problem is that's kind of complicated for a lot of people. So what we do is we sometimes draw them into tables, and that helps represent it differently. So next page, if you look, okay, let's put it into tables. Maybe this will make more sense to you, right? So what we have here is we have 3 variables, same thing, times 2 variables, and they're both positive. So on the top, we have 2b, again, whatever variable we want. The side, we have 3b, and they're both positive. So we do this. Now, if you look, this one times this one yields a big one. This one times this one yields a big one. And then all we do is fill in the rest of the table. So 2b right here, which is this one, times 3b, which is this one, yields us 6 of these guys, all positive. So yields us 6b squared. So that may make a little more sense to those that were having trouble on the previous page. Now, those were both positives. Let's throw some negatives in, see what that does. Next one. So what we have here on the top is we have whatever variable we want. We use b in this case. So we have negative 2b. Here down the side, we have positive 3b. And remember, a negative times a positive is a negative, so these are all going to be dark. And you can see we represent, we end up with 6b squared. Oh, that's kind of cool. Just a different way to represent what we did algebraically in a physical form. Okay, let's do one on the next page. Let's see, they're going to get complicated. So here what we got, oh boy, this is neat. What do we got here? Down the side, we got, these are negative 3b. There it is right there. Yeah. Across the top, we have negative 2b plus 2, right? Remember, we can represent that. That's a binomial. So if we wanted to, we could do distributive property, right? This is the algebraic way. Negative 3b times negative 2b. We're distributing negative times a negative is a positive. B times b is b squared. That's easy. Negative 3b times positive 2 is negative 6b. So again, some of you can do it algebraically, fine. If you need to do it with a picture, do it that way. It's up to you. So here we got a negative times a negative, which is a positive, big one. Negative times a negative, which is a positive. Negative times a positive, which is a negative. And negative times a positive, which is a negative. So you basically can fill out the whole thing. Now, if you look at this, look at the first part. Look how many big squares we have here. They're all positive. We got 6 of them. So that's our 6b squared. And then we have 6 of these negative ones here, and these are just b. So minus 6b. Okay? Now, that's multiplying. What if it's dividing? Well, we can do this. There's 2 ways of doing it. We can do it algebraically, which a lot of you will get right away. So we have 8x plus 10 on the top, and we're going to divide everything by 2. Now, you got to remember, this 2 you're dividing this piece by 2, but you're also dividing this piece by 2. That's the rule. You have to be able to divide it into 2 pieces. So what I recommend doing is break it apart. So 8x divided by 2 plus 10 divided by 2. That way you won't forget that you have to divide both parts by 2. And this is quite easy. 8x divided by 2, 8 divided by 2 is 4x. Simple. 10 divided by 2 is 5, right? So algebraically, it's not really difficult. But if you want to do it with algetiles, what you got to do is, since we're dividing by 2, we got to take the entire group and break it into, in this case, 2 equal pieces. So if you look here, so 8x plus 10, let's write it out here. So 8x is going to be 8 of these rectangles, light colored because they're positive, and 10 of these little blocks because that's the positive 10. And what we can do is we can break this evenly into 2 pieces, and that's what this line is in the center here. Hey, we broke it evenly into 2 pieces. So what do we have as an answer? Well, that's going to be our solution. So we have 4 of those and 5 of those, so it's 4x plus 5. So that top part is algebraically, and the bottom part is algetile. Okay, last page of this lesson. So now you get a more complex one. Ooh, 3w squared minus 6w minus 9 divided by 3. Now you got to remember, this 3 has to go into everything. So if you want, you can break it down. 3w squared divided by 3 minus 6w divided by 3 minus 9 divided by 3, right? This is algebraically. So 3 divided by 3 is 1, so we just end up with a w squared. Negative 6 divided by 3 is negative 2, right? And the w is just there. And then negative 9 divided by 3 is negative 9. So that's algebraically. Now, if you want to do this with algetiles, the key difference here is you've got to break it into how many groups? 3 groups. So we draw out everything. So we have our 3w squared. So we're going to have 3 big squares. Negative 6w, we're going to have 6 black ones here. So 1, 2, 3, 4, 5, 6. And then we have negative 9, so we need 9 of the dark squares. Break it into 3 groups. There's our lines, 1 and 2. So we have 3 groups. Yeah. So what are we left over with? Well, that's what it's going to be your answer. So we're left with positive w squared minus 2w minus 3. So again, algebraically, algetiles. You decide. Okay, so that's the end of lesson 5.5, 5.6, and then the rest of the time we're just going to be spent working on the questions that go with this stuff. And again, we're either going to do it algebraically or algetiles, depending upon which way you like better.